Hello students, in this session
Let us solve a question on bending stresses. A simply supported beam of width 100 mm, height 200 mm and length 4 meter is carrying a UDL of intensity 10 kN per meter. We have to find the maximum bending stress in the beam. So we are given with a simply supported beam is there. This is simply supported beam. One is the hinge joint, another is the roller joint. 4 meter length of the beam is given and the UDL is given 10 kilonewton per meter. This is a uniformly distributed load. This is given to us. We have to find out the maximum bending stress in this beam. So let us solve this problem.
in this question we are given with a simply supported beam loaded with a UDL of 10 kN per meter. The length of the beam is 4 meter and the cross section area is 100 by 200 millimeter square. We have to find out the maximum bending stresses in the beam, right? From the bending equation we know M by I sigma by Y E by R. This equation is known to us, right? From here sigma is equal to My by I. If we want the maximum bending stress, then we have to take the point where the bending moment is maximum. So maximum bending moment should be considered, and the fiber y is the distance of the fiber from the neutral axis. So the fiber should be maximum. The distance should be maximum, right? So we will consider the y max. This is the y max. Outer fiber, right? So outer fiber will be maximum, y max, right? Outer fiber will be maximum. So maximum distance should be taken from the neutral axis, because this y is the distance from the neutral axis. Then we will get the maximum bending stress. So we will get M max, Y max, I. But how to find out maximum bending moment? For that we have to draw the bending moment diagram. So let us draw the bending moment diagram. Let us draw the bending moment diagram. We have already done this in our shear force and bending moment theory lecture, that what is the bending moment diagram for this simply supported beam with UDL, right? So you will get a parabolic curve like this, and maximum bending moment will be at the center, right? Suppose this is the center C, so maximum bending moment will be at the center, right? You can see, you can check in the bending moment, shear force and bending moment diagram chapter. You can see there the maximum bending moment will be at the center, and the value will be WL square by 8. You should remember this thing also. WL square by 8, where W is the load per unit length, L is the length of the beam, and divided by 8, right? So this is the maximum bending moment. Basically this is M max. So M max will be given by W, that is 10 kilonewton. For kilo we are multiplying 10 by 3. So L square is 4 square upon 8, right? So this is the, and solve it and you will get the maximum bending moment. So it will come out to be 20 kilonewton meter. So maximum bending moment is 20 kilometer. What is Y max? Y max? So that will be equal to the maximum fiber, the distance of the fiber, outer fiber, right? So Y max. So this is 200 total length, so it will be 100 millimeter, right? So this will be 200 by 2, that is 100 millimeter. So we have got M max, Y max. What is I? Moment of inertia. That is BD cube by 12. BD cube by 12. So that will come out to be B is 100, 200 cube by 12. This will be the bending moment, right? Put these values in this and you will get the maximum stress, sigma max. That will be equal to M max. M is in kilonewton meter. We can convert it into millimeter, so that answer may come in megapascal. So 20 kilo, for kilo we have multiplied 1000. For meter we have multiplied 1000 again to make it millimeter. So now it is Newton millimeter. Y max is 100 millimeter. All things are Newton and millimeter, so answer will come in Newton per millimeter square, and BD cube by 12 is 100 multiplied by 200 cube by 12. This is moment of inertia. And finally solve it and you will get the answer. So answer will come out to be 30 megapascal. Solve it using calculator and find the answer. So sigma max is 30 megapascal. So this is the answer, right? First you find out the maximum bending moment and then solve it using the bending equation.